So we assume that you are able to use Pandat from Computherm, so you have downloaded the software from this site, and well, now I should share the window with the software somewhere over there. Yes, I'm using the educational version like you are. Well, you will find, while opening the software, this arrangement, which is typical of any software you are going to use. So the main commands are over there. There are several windows, and we will see what you can do. First of all, File, create a new workspace. We will build the iron carbon phase diagram, which is the first step for using this software and probably for beginning the use of something related to computational metallurgy as well. Maybe I will switch off the camera if I can. Well, never mind. So you have now started the software. First of all, you need a database. A database could be commercial. In this case, it will be encrypted, or it could be open. We will use basically open databases. I have my open databases over there, and I will use the FE Miani 2018. So I will open it. I will have some warnings. No problems if I have warnings. I will select iron and carbon, iron and carbon. Now I have selected them, and I will go in this window, which is section calculation, and I will calculate the iron carbon phase diagram on the basis of that thermodynamic database that I have opened. If I would open other databases, the thing would be different, probably completely different. And that's the point. So let us start with some 10% of carbon and 90% of iron. So we will have 3 points there in the origin and for the X point. But along with using the software, the thing will be clearer, I hope. Okay, so we have selected, we have loaded a database, we have selected the elements, iron and carbon, and now we say, okay, we have been in this window, which is section 2D calculation. And then section 2D calculations will allow you in a while to have the full picture of our iron carbon phase diagram. And you see, now you can do with your clicking with your right mouse on any area of your plot, and you can add labels. Labels are phases. So we see here going in different area of this iron carbon phase diagram to see different phases. I assume that you already have the concept of phase, as long as you have been attending some material science courses as well. Now, as for steels, we know that graphite is nothing that we will find in our steel. So we can do the same cut. This could be nice, partly nice for cast iron, which is not the topic of this course. So Could be not, but I will again have the possibility to have some options. So in your menu, because if you have just started, you will select weight percent, this W percent, and you will also select Celsius temperatures as well. And that's nearly everything. But in the plot setting, probably you should add something for viewing the text and the legends with a font which is bigger than 8.25 that it is in the setup of the software. So I've already done it, but do not bother if you have not done it. The important thing that we are now selecting phases. So I have a lot of phases there because it is a database for many elements and for many phases, but what it is to exclude, it is graphite and also this diamond A4. And now you have this possibility, which is the standard iron carbon phase diagram, but with cementite, which is iron carbide F3C as a phase instead of graphite. Again, we will use label. We are interested in steels, nothing more than 2% in carbon. So everything you would see here is unrelated to what we are discussing, but we can add labels and see what's going on. So forget about anything that would go more than 2%. So now I will tell you that we can view different windows, which is typical of any Windows or any modern software. So we can have a look at the property window, perhaps shutting this one. And so I don't want to see this 10% any longer. I would like to see, let's say, 2.1 maybe. Yeah. Now we have a view of what is more important for us. Which is, I should shift it there, which is the typical representation of the iron carbon phase diagram. Normally you have been studying it before, but you have not been calculating it before. So it is okay, and we will see if you will be able to do that. This software is quite powerful, even in the student or demo mode. So we have done section calculations. I would use line calculation, and possibly I will use, but for this, we will see what we need, phase projection. So let us go into line calculation. And let us assume that we will make a calculation for a steel with 1% carbon here. And I will, and going from 20 Celsius degrees to 15, 20 degrees. So carbon 1 and 1 here. And then with your mouse, you can replace, with right mouse, you can replace the value with the remainder. Sometimes it's useful, or you can type yourself what it is remainder up to 100. Okay? We still have selected to suspend this couple of phases, diamond and graphite. And now we have just to make this line calculation. We'll see what's going on now with your mouse, right button. You will select not label, but legend. And here it is the legend of different colors you can have here. So we are still considering only 4 phases, VCC A2, which we would call also ferrite, cementite or iron carbide. This is FCC A1, which is austenite, and this is the liquid phase. These are atoms on atoms, so it is up to 1%, well, not percent, up to 1, so ratios in the temperature range that we want. And here we can see for the letting the cementite in, but if we want to do this calculation again and re-include those phases like that, we will obtain a different situation. Let us again use legend. So we will see that we have, yes, we still have cementite, but we have still graphite. So this one is to forget, as I told you before, but it is just an example. Maybe more interesting is to make a solidification simulation over there. This is a schematically, it is a ladle, the one container that you are pouring the steel from the furnace. Typically, in my mind, it is from an electric arc furnace. So let us make a simulation of a solidification with the same composition that I told you before. So 1%. And now I want to exclude those phases, which will be typical of my things for this course. Okay, so this is so-called child simulation. If you are using the lever rule, you've been studying in the courses of material science before, you can still make this solidification simulation, and you will obtain a different graph. So what about this graph? We have solid fraction here and temperature. So this solid fraction 0 means that there is nothing solidified. This solid fraction 1 means that everything is solidified. So using the lever rule, we can have a look and see what's going on over that temperature range. So here you can have a look there. So it is something like 1463. You have the beginning of the solidification, and here solid fraction Fs1, you have the final solidification. Which is the difference? Well, first of all, we can see the difference. So copy data and then paste data. So the red line is the lever rule. Let us see what's going on with legend. So here we can blue, it is child. And here it is lever rule. We can move it somewhere else if we can. So the point is that we have here we follow the equilibrium phase diagram and the Lagrange. Here we assume that once the solidification is starting, the atoms wouldn't move at all in the solid phase. So you have something which is solidified, and then the atoms will be there forever. On the other hand, the equilibrium, so the minimization of the energy function global, would be following this line, and you will obtain quite different. So there is a difference here in solidification temperature of something like 250, which is a lot, degrees. Which is the right one? Well, it depends on the real solidification conditions. We are using thermodynamic data, basically. So we are not able to couple anything related to the dynamics, so with the devolution of time. So you would need kinetic data, which is rather more complex, especially for the first example lecture on the use of a software. It is possible to do even with this software, but you should have good databases. And so we will see what we can do as a demo in this software, but probably we will not use for much more than examples already produced in this package. Where you would find examples, help. So you will find an L file here. Also, it would work because it should be. And if it does, let us stop our 20 minutes talk. Something went wrong, but I think we can fix it. Maybe it is not the right, it is not the last version, but there is an L file, an example file. We will see right in the next 20 minutes talk, okay? That's all for the moment.